In this video, we're learning how to solve rational inequalities. And if we take a look at example 1, we have the quantity of x plus 5 divided by the quantity of x minus 3 is less than or equal to 0. So when we're solving rational inequalities, what we want to figure out first is what numbers or what x values make the numerator and denominator of our fraction equal to 0. So we're going to start by doing is setting the numerator and the denominator equal to 0 and solving. So if we set the numerator equal to 0 and we solve, we can subtract 5 from both sides. We're going to get x is equal to negative 5. And if we set our denominator equal to 0, so we have x minus 3 equals 0, and we solve by adding 3 to both sides, we're going to get x is equal to 3. And these numbers are going to be really important when we're solving problems like this. So these numbers are going to be the numbers that we're going to put on a number line to make what's called a sign chart. So we're going to put x equals 3 and x equals negative 5. And now before we actually start testing our sign chart, we want to think about whether or not our x values can actually be negative 5 and 3. So if we look at negative 5, we know that if we plug a negative 5 into this top x, right, it's going to turn our entire numerator to be 0. The denominator will just be some number, but the numerator will be 0, so our entire fraction will be 0. Our problem says that our polynomial can be less than or equal to 0. Which means that we know if we plug in negative 5 for x, it makes this inequality true because we'd have 0 is less than or equal to 0. So we know that negative 5 is going to be a solution to our inequality. So I'm going to start by putting an open circle, a closed circle at negative 5. And now we have to think about what happens if we plug in x equals 3. If we plug in x equals 3 into the denominator, let me just erase it from the numerator. If we plug it in down here, it's going to make our denominator 0. It'll make our numerator just a positive 8. If we have a 0 in our denominator, we get an undefined answer. So we cannot put a 3 into our inequality because it'll make our denominator 0. So we're going to put an open circle at 3. And now what we need to do is test each part of our number line. So we need to test this left part over here. We need to test this middle part. And we're going to test this right part. And we need to see what's going on with our inequality. So what we're going to do is pick a number in each of these intervals and plug it into our original inequality, and we can just plug it into this left part over here, and we want to figure out if it comes out as negative or positive. So let's do this pink part to the left of negative 5 first. We need to pick a number that's less than negative 5. So let's test x equals negative 6. So we're going to take our original expression, so we have x plus 5 over x minus 3. And we want to replace our x's with this x value of negative 6 that we chose. So we're going to do negative 6 plus 5 over negative 6 minus 3. And negative 6 plus 5 is negative 1. And negative 6 minus 3 is negative 9. A negative over a negative is going to come out as a positive, so I'm just going to write that it comes out positive. So I'm going to put a positive in this part of our sign chart. So we know that our inequality will always be positive to the left of negative 5. So now we need to test something in between negative 5 and 3, where this blue arrow is. So I will test x equals 0 because it's an easy number to test. So we're going to use our original expression of x plus 5 over x minus 3. And we need to replace x with 0. So we have 0 plus 5 over 0 minus 3. And we're going to get a positive 5 over a negative 3. A positive over a negative is negative. So I'm going to put a negative. So I know that in this middle part of our number line, our expression of x plus 5 over x minus 3 is always going to be negative. And now we need to test something in this right interval. So we need a number that's greater than 3. So let's test x equals 4. So again, let's write our original expression of x plus 5 over x minus 3. And we're going to replace x with 4. So we're going to say 4 plus 5 over 4 minus 3. And 4 plus 5 is 9. 4 minus 3 is 1. We have a positive over a positive, so we're going to get a positive. So I'm going to put a positive in this interval. So now we found that this expression of x plus 5 over x minus 3 is going to be positive for any x values below negative 5. It's going to be negative for any x values between negative 5 and 3. And it's going to be positive for any x values above 3. So if we look at our original inequality, we know that we're trying to figure out when that expression of x plus 5 over x minus 3 is less than or equal to 0. So we're trying to figure out when it is equal to 0 or negative. So we want to look at this section of our number line that is negative, and that's where our solutions are going to be. So now we're just going to write this as an inequality. So we can write this as negative 5 is less than or equal to x, because remember x can equal negative 5, and x is less than 3, and x cannot equal 3, so we're not going to have a line under that part of our inequality. And if we want to write this in interval notation, we can put a hard bracket at negative 5, because x can equal negative 5, and it can equal anything up to 3. We're going to put a soft bracket because x cannot equal 3, so we can write our answer either of these two ways. Let's go through some more examples. So if we take a look at example 2, we have x squared minus 6x minus 16 all over x plus 4 is greater than 0. And this time we have a trinomial in the top of our fraction and a binomial in the bottom. For the first example, we just had a binomial in the top and bottom. So what we want to do for this problem is first factor the top, because remember our goal is to figure out what makes the top and bottom of our fraction 0, and in order to do that we need the top and bottom to be factored. So we're going to start by factoring this trinomial on the top. So we need to think of two numbers that multiply to negative 16 that add to negative 6. And if you take a second and think about that, you should get negative 8 and positive 2. So we can factor it into x minus 8 times x plus 2. And our denominator is going to stay as x plus 4 because we can't factor it. And we have that this is greater than 0. And now what we want to do is figure out what makes our numerator equal to 0 and what x value makes our denominator equal to 0. So for the numerator, we're going to set x minus 8 equal to 0 and solve, and we're going to set x plus 2 equal to 0 and solve. If we solve x minus 8 equals 0, by adding 8 to both sides, we get x equals 8. If we solve x plus 2 equals 0, by subtracting 2 from both sides, we get x equals negative 2. And now for the denominator, we're going to set x plus 4 equal to 0. If we subtract 4 from both sides, we get x is equal to negative 4. And now remember, these numbers are important because those are the numbers we're going to put on our number line or our sign chart. So we need negative 4, negative 2, and positive 8. And now before we actually start testing the different parts of our sign chart, we want to think about whether or not negative 4, negative 2, and 8 are solutions to our inequality. So let's look at negative 4 first. If we plug in negative 4 into the bottom of our expression, it's going to make our denominator 0. And remember, we can never have 0 in the denominator of a fraction because it is undefined. So x cannot equal negative 4. So we're going to put an open circle at negative 4. Now, if we look at the other two x values, so x equals 8 and x equals negative 2, we know that if we plug these in up here, so if we plug in x equals 8 into this expression x minus 8, it's going to make it 0. And then it's going to multiply by some numbers and divide by some numbers. But 0 multiplied by something and divided by something is just 0. So we know if we plug in x equals 8, it's going to make the left side of our inequality equal to 0. Well, we know that it has to be greater than 0. The left side of our inequality cannot equal 0. So this time, x equals 8 is not a solution. So we're going to put an open circle at 8. I'm going to erase this. And we still have this greater than sign. And now the same thing with negative 2. So if we plug negative 2 in here, it's going to make this factor 0, and it's going to make the entire left side of our inequality 0. But because we need the entire left side to be greater than 0, x cannot equal negative 2. So we're going to have open circles at all of these three x values on our number line. And now we want to do what we did in example 1 and test every interval. But this time we're going to have 4 intervals. So we have this left interval, we have this interval between negative 4 and negative 2, we have an interval between negative 2 and 8, and we'll have this interval over here of greater than 8. So we need to pick a bunch of x values. So let's first pick an x value in this left interval. So let's say x is equal to negative 5, because that is to the left of negative 4. We're going to take our factored version, so x minus 8 over x plus 2 over x plus 4, and we want to see what happens when we plug in negative 5. So we'll have negative 5 minus 8, we'll have negative 5 plus 2, and we'll have negative 5 plus 4. And now we just want to see what our sign is going to come out to. So negative 5 minus 8 is going to give us a negative 13. Negative 5 minus 2 is going to give us a negative 3. And negative 5 plus 4 is going to give us a negative 1 on the bottom. So we have two negatives being multiplied and then divided by a negative. So we have three negatives, which is going to turn out as negative. So we don't actually have to find the value of this, we just have to know that it's negative. So I'm going to put a negative in this part of our sign chart up here. Now we have to pick a number between negative 4 and negative 2. So let's say x is equal to negative 3. Again, we're going to plug it into this factored form. So I'm not going to rewrite this factored form for the sake of time. I'm just going to go ahead and plug in x equals negative 3. So we're going to have negative 3 minus 8 times negative 3 plus 2 over negative 3 plus 4. Negative 3 minus 8 is negative 11. Negative 3 plus 2 is negative 1. And on the bottom, negative 3 plus 4 is positive 1. So this time we only have two negatives being multiplied and then divided by a positive. So this is going to come out as positive. So I'm going to put a positive in this part of our sign chart. For the green section, we need a number between negative 2 and 8. So let's just say x equals 0. Again, I'm going to plug it into this factored form to the left. That's in yellow. So we're going to have 0 minus 8 times 0 plus 2 over 0 plus 4. 0 minus 8 is negative 8. 0 plus 2 is 2. 0 plus 4 is 4. We have one negative and two positives, so this is going to come out as negative. So I'll put a negative in this part of our sign chart. And finally, we have to test this right part. So we need something greater than 8. So let's just test x equals 9. So let's plug in 9 to this factored form. So we have 9 minus 8 times 9 plus 2. And then over 9 plus 4. 9 minus 8 is going to give us 1. 9 plus 2 is 11. 9 plus 4 is 13 on the bottom. We have all positives, so we know this is going to come out as a positive. So I'm going to put a positive in this part of our sign chart. And now we have to look at our original problem. So in our original problem, we're trying to figure out when this rational expression is greater than 0. So we want to figure out when it's positive. So we're going to shade the parts of our number line that are positive. This blue part right here and over here to the right. We're going to shade. And now we have to write our answer as an inequality. So first I'll write it as an inequality just in standard form, and then I will use interval notation. So we can write it just using normal inequalities as x is going to be greater than negative 4, but it's going to be less than negative 2. Or, because we have a break in our number line, x is greater than 8. And if I want to write this in interval notation, if I want to write x is between negative 4 and negative 2, but can't equal negative 4 and negative 2, I'll put a soft bracket at negative 4. It goes up to negative 2 with the soft bracket. Instead of or, we're going to put this u, which means union. And we're going to have x can be from 8, but not including 8, all the way up to infinity. And we always put a soft bracket with infinity and negative infinity. So we can write our answer either of these ways. Let's go through some more examples. So example 3 is 2x minus 8 all over x plus 4 is greater than 6. So this time we don't have a 0 on one side of our inequality. So that's what we're going to have to do first. So what we're going to want to do first is get everything to the left side. So we're going to subtract 6 from both sides of our inequality. So we're going to get 2x minus 8 over x plus 4 minus 6 is greater than 0. And now we have to turn the left side into one fraction. So we're going to have to make a common denominator between 2x minus 8 over x plus 4 and this minus 6. So what we want to do is make minus 6 have a denominator of x plus 4. So what I'm going to do is over here, we're going to keep 2x minus 8 as it is over x plus 4. And to make negative 6 have a denominator of x plus 4, we're going to have to multiply the top by x plus 4 and the bottom by x plus 4. And we know this is greater than 0. And now we're going to have to simplify this and combine it. So now that our two fractions have the same denominator, we can just write it as one big fraction that's over x plus 4. So we're going to have 2x minus 8. And now we want to distribute this negative 6 in. So we have negative 6x. And then negative 6 times 4 is negative 24 is greater than 0. And we need to combine like terms on the top. So we're going to have we have 2x minus 6x is going to give us a negative 4x. Negative 8 minus 24 is negative 32. And that's over x plus 4. And this is greater than 0. And then over here, now we need to factor the top. So we're going to take a negative 4 out. We're left with x plus 8. And that's over x plus 4. And this is greater than 0. So we just combine the negative 6 with this 2x minus 8 over x plus 4 by making a common denominator. And then we have to factor the top because our goal is to figure out what makes the numerator and denominator of our fraction equal to 0. So now what I'm going to do is actually just erase what we just wrote so that we have some space, and I will rewrite our simplified inequality right here. So we have negative 4 times x plus 8 over x plus 4 is greater than 0. And now what we want to do is find the x values that make our numerator and denominator equal to 0. So we're only going to look at the factors in the numerator and denominator that have an x. So we're going to look at this x plus 8. We're going to set it equal to 0. And we're going to look at x plus 4, and we are going to set it equal to 0. And we're going to solve. So for x plus 8 is equal to 0, we're going to subtract 8 from both sides to get x equals negative 8. And for x plus 4 is equal to 0, we're going to subtract 4 from both sides to get x is equal to negative 4. And now we want to put those numbers on a number line. So we're going to put negative 8 and negative 4. And we first want to determine if negative 8 and negative 4 are part of our solutions. So we have that our entire left side of our inequality has to be greater than 0, so it cannot equal 0. We know that if we plug in negative 8, it's going to make this factor up top equal to 0, so it'll make our whole fraction 0. Since we need it to be greater than 0, negative 8 is not a solution. We know if we plug in negative 4 into our denominator, it's going to make the denominator 0, which will make our entire fraction undefined. So negative 4 is also not a solution, so we're going to put open circles there. And now we need to test each part of our number line. So we need to test this left part, this middle part, and this right part. So let's test the left part first. We need a number to the left of negative 8. So let's just choose x equals negative 9. And we're going to plug it into this factored form of the left side of our inequality. So negative 4 times x plus 8 over x plus 4. So we want to replace x with negative 9. So we have negative 4 times negative 9 plus 8 on the top. On the bottom, we're going to have negative 9 plus 4. So on the top, we're going to have negative 4, and then negative 9 plus 8 is negative 1. And on the bottom, negative 9 plus 4 is negative 5. And now we're just going to simplify this. Or actually, we don't even have to simplify. We're just going to figure out if it's positive or negative. So we have 2 negatives on the top and 1 on the bottom. So it's going to come out as negative. So we're going to put a negative in this part of our sign chart. And now to test the middle section, we need a number between negative 8 and negative 4. So let's just pick x equals negative 6 and plug that in to this factored form right here. So we're going to have negative 4 times negative 6 plus 8 over negative 6 plus 4. And let's simplify this. We have negative 4, negative 6 plus 8 is positive 2, negative 6 plus 4 is negative 2. So this time we have 2 negatives, so our answer will come out as positive. So we're going to put a positive in this part of our sign chart. And finally, let's test the right side of our sign chart. So we need a number to the right of negative 4, so we could just pick 0 because it's easy. So we're going to do negative 4 times 0 plus 8 on the top. On the bottom, we're going to have 0 plus 4. On the top, this is going to simplify, so we have negative 4, and 0 plus 8 is 8. And on the bottom, 0 plus 4 is 4. So this time we have 1 negative, so our answer is going to come out as negative. So we are going to put a negative here. And now we want to look at our original problem. We are trying to figure out when the left side of our equation is greater than 0, so when it's positive. So our answer is going to be in this middle section right here. So we know that x is going to have to be between negative 8 and negative 4, not including those two. So we could write it like this, or we could write it in interval notation using soft brackets from negative 8 up to negative 4. And let's just go through one more example just to make sure that we really understand this. So for this last example, we have 9 over x minus 6 is less than or equal to 3 over x minus 3. So what we want to start by doing is getting everything to one side of our inequality. So I'm just going to subtract this 3 over x minus 3 from both sides. So I'm going to have 9 over x minus 6 minus 3 over x minus 3 is less than or equal to 0. And now we have to make a common denominator. So the least common denominator between x minus 6 and x minus 3 is just going to be both of those factors multiplied together. So it'll be x minus 6 times x minus 3. So what I'm going to do is just write that as the denominators for both of our fractions, and then I'll show you guys how to manipulate our fractions to get those denominators. So we're going to have x minus 6 times x minus 3 in the bottom of both. In order to change 9 over x minus 6 to have a denominator of x minus 6 times x minus 3, we have to multiply the top and bottom by x minus 3. In order to change 3 over x minus 3 to have a denominator of x minus 6 times x minus 3, we have to multiply the top and bottom by x minus 6. And we know this is less than or equal to 0. And now we just have to simplify all of this. So we're going to start by distributing the 9 and the 3. So we're going to get 9x minus 27. And I'm going to distribute this negative 3. So negative 3x. And we're going to distribute the negative 3 to the negative 6 to get positive 18. And we can combine the fractions together because they have the same denominators. So it's going to be over x minus 6 times x minus 3. This is less than or equal to 0. And now I have to simplify the top. So 9x minus 3x is 6x. Negative 27 plus 18 is going to give me a negative 9 on the top. And this is over x minus 6 times x minus 3. This is less than or equal to 0. And now we just want to factor this so that we can figure out what makes our numerator and denominator equal to 0. So we can pull a 3 out of the 6x in the minus 9. So we'll have 3 times 2x minus 3. And on the bottom we have x minus 6, and x minus 3 is less than or equal to 0. And I'm going to do what I did last time. I'm going to erase all of this and just write this simplified version so that we have more space to finish the problem. So now what I want to do is figure out what makes my numerator and denominator 0. So I'm going to set each factor that has an x equal to 0. So for the numerator, we have 2x minus 3 equals 0. We can solve this by first adding 3 to both sides, to get 2x equals 3. Divide both sides by 2 to get x equals 3 halves. And for the denominator, we're going to set x minus 6 equal to 0 and x minus 3 equal to 0. We can add 6 to both sides to get x equals 6. And for our other equation, add 3 to both sides to get x equals 3. And we're going to put those numbers on a number line. So we're going to have 3 halves, 3 and 6. And now we have to figure out if these are part of our solution. So x equals 3 halves makes the numerator equal to 0. And we know that our whole left side of our fraction can equal 0. It can be less than or equal to 0. So this time 3 halves is a solution, so we are going to put a closed circle. We know that x equals 6 and x equals 3 make our denominator 0. So if we plug them in here, it's going to make the denominator equal to 0, which is not allowed in math. So we know that x cannot equal 3 and cannot equal 6. So we're going to put open circles there. And now we need to test each part of our number line. So the left part, we need to test in between 3 halves and 3, in between 3 and 6, and to the right of 6. So now we need to pick some values and plug it into this factored form that we found. So let's pick a number to the left of 3 halves. So let's just pick x equals 0 for this left part of our number line. And we're going to plug it into this factored form, which is 3 times 2x minus 3 over x minus 6 times x minus 3. And we want to figure out if it's positive or negative. So we're going to plug in 0. So 3 times 2 times 0 minus 3 over 0 minus 6 times 0 minus 3. And if we simplify this, we're going to have a 3, and then in the parentheses on the top, 2 times 0 is 0, minus 3 is just minus 3. On the bottom, 0 minus 6 is negative 6, and 0 minus 3 is negative 3. We have 3 negatives, so this is going to come out as negative. So this section of our number line is negative. So now let's pick a value in this blue part of our number line. So something between 3/2 and 3. So let's pick x equals 2. Plug it into this factored form that we were using for x equals 0. So we're going to have 3 times 2 times 2 minus 3 on the top. On the bottom, we have 2 minus 6 times 2 minus 3. And we're going to simplify this down here. So on the top, we have 3 on the outside. 2 times 2 is 4. Minus 3 is 1. On the bottom, 2 minus 6 is negative 4. 2 minus 3 is negative 1. So we have 2 negatives. So this is going to be positive. So we're going to put a positive in this part of our number line. Let's test this green section. So something between 3 and 6. So let's just test x equals 4. Put in our factored form. So 3 times 2 times 4 minus 3 on the top. On the bottom, we are going to have 4 minus 6 times 4 minus 3. And we're going to simplify this. So on the top, we have 3. 2 times 4 is 8. Minus 3 is 5. So 3 times 5 on the top. On the bottom, 4 minus 6 is negative 2. And 4 minus 3 is positive 1. We have 1 negative, so this comes out as negative. Put a negative in this part of our sign chart. And finally, we have to test this right part. So we need something bigger than 6. So let's test x equals 7. So we're going to have 3 times 2 times 7 minus 3 on the top. On the bottom, we have 7 minus 6 and 7 minus 3. Simplify the top, we have the 3 on the outside. 2 times 7 is 14, minus 3 is 11. On the bottom, 7 minus 6 is 1. 7 minus 3 is 4. We have all positives, so we know this is going to come out as positive. Put a positive in this part of our sign chart. And now we look at our original problem. We're trying to figure out when the left side of our inequality is less than or equal to 0. So we want to figure out where this is negative. So we're going to shade where it's negative. So it's these parts of our number lines, and I'm going to write this using interval notation. So we know it could be anything from negative infinity all the way up to 3/2, including 3/2. So we're going to put a hard bracket there. And because we have 2 parts of our answer, we have to put this u, which means union. And we can go from 3 to 6, not including 3 and 6, so we're going to put soft brackets. So this is how we write our answer. So hopefully that video helped you guys learn how to solve rational inequalities. These are pretty challenging problems for a lot of students, so I encourage you guys to check out the link in our description for a free practice worksheet, which has tons of practice problems similar to what we did today, plus answers at the end.